Assalamualaikum, my name is Taufik Hidayat. So today I will present about the simulation and the performance analysis of dual input single output DC-DC converter for renewable energy application. The objective of this project is to design and simulate a dual input single output DC-DC converter. The second one is to analyze the performance of the DC converter. The third one is to evaluate the effectiveness of the proposed system under varying input condition. The project approach, the first one is simulation of the converters, and then the second one is analysis of the converter on efficiency using solar PV and voltage source. The third one is to ensure the converter can effectively manage power distribution from renewable source. There are two tools that we use, which is PSIM and also Excel. For tools description, why I use PSIM for this project? Because the first one is faster and more efficient than general purpose simulators for power electronics. The second one is ideal for academic research and industrial development. The third one is allows rapid prototyping of control and power system. Here's the interface of PSIM. You can see file manager, component library, simulation setups, simulation interface, and also the ribbon. So for the demo, we will start with construct the circuit. All the components can be obtained in the components library. The second one, connect all the components based on the converter connection. Here are two circuits of open loop and also closed loop. The third one is insert all of the calculated and assumed parameters. The fourth one is set up the simulation control and run the program. The last one is obtain the result from the graph and also tables. So this is the simulation for the buck converter using renewable energy. We can click for the simulation and then we run it and we can choose which parameter that we want, and I choose V in, V into, V out, and also I out. Click for measure, we can get the table, and also we can zoom a bit to get the clearer view of the waveform, and we can make it more bold for the y-axis and also x-axis. So that's how we get the result for the simulation. The result can be obtained from the graph from the simulation. So here's the three conditions for buck DC-DC converter open loop. So for condition 1 is when S1 and S2 is on. Condition 2 is when S1 is on, S2 is off. And the last condition is when S1 is off, S2 is on. We will observe the V out, I out, V in 1, V in 2, power out, and also power in. Next, after we obtain the result or data from the simulation, it will be transferred into table into the Excel. This is because it will make more easy for us to do the calculation for the efficiency by using formula P out over P in times 100. After we obtain the efficiency, the data analysis will be displayed in graph by using Excel, so it will make more easier, more simpler for us to see the result. For two limitation, support control design it is not as comprehensive as MATLAB and also Simulink for complex control system analysis and advanced mathematical modeling. The second one is component library limitations, and the last one is a basic graphical interface. So for the conclusion, buck converter, it is high efficiency voltage step down, simple circuit design, low power losses and stable output, and it also support two input source for DSO system. But it cannot increase voltage, possible output ripple if poorly been designed. For the solar PV, the output voltage stability when I'm using single solar PV source, it will be less stable when irradiance drop. But for dual solar PV source, it will be more stable because one PV can support when the other is weak. For the design complexity, it is simpler circuit design and easier to improve for single solar PV source. But for dual solar PV source, it will be more complex. The suitable application range for single solar PV source it will be more suitable for low power system. But For the dual solar PV source, it will be more suitable for both low and also medium power system with improved reliability.